Right. Starting up with unit number 5, friction. Some of the parts of this, the basic idea of this already we learned in the last lesson when we were discussing about these force. Can I remember? Unbalanced force we spoke about, right? Okay. So under that unbalanced force, we discussed there is an opposing force to the motion of an object in motion. Okay, object in motion. When you try to move an object, there will be an opposing force, and we're gonna learn in detail. Okay, what is this? So we're speaking about few topics. It's a very small and a simple lesson. We learn first the concept of force. What is force? And then the types of force. The types of this frictional force. Actually, what is the frictional force? And then the types of frictional force. Okay, how to identify them. Then we come for factors affecting the frictional forces and the factor which will not affect the frictional force. And advantages, disadvantages, how to use them. Increasing, decreasing friction. These are the topics. Right. So how do we define this friction? First, say it is the force. It is a force acting between two contacting surfaces. So the first point you learn here, friction to take place. Friction to take place. There should be two contacting surfaces. Okay. Let's say this is the object. This object in air when you are moving, you don't have a friction. But there is another word. It's also a sort of resistive force. But that force we don't learn in grade 10 level. That is air resistance. Air resistance is also a sort of resisting force. A force against the motion. Right? So here, two surfaces should be there. Let's say the board and the dust right? Both should be contacting on one another. Okay? That's the first point. Or else the duster and the table should be contacting. Should be contacting on one another. Okay? So let's say it should be contacting on one another. Right? Without contacting two surfaces, you can't speak about the friction here. That's the first point. And the second point, just keeping in this way, there is no friction. You keep an object, okay, two contacting surfaces are there. Just because of two contacting surfaces they are here, there is no friction. Because friction means it is the force acting against the movement, the motion. Means you have to try to move this object first. You have to apply a force to move the object. Okay, you have to apply a force to move the object horizontally. But this happens in three conditions. I mean, three instances. There are three types of friction. Whatever. When you apply a force, when you start applying a force to move this, there it starts the friction against your motion. You try to move it in one direction. To my left, you try to move opposite direction. There will be a friction given. And this friction is given in between the contacting surfaces. None of the forces you can see. You are giving a force, you know that you are applying a force to pull or push. So the opposite direction of your force, from between the contacting surfaces, there will be a force given. And that force is given by the second surface. Means this is the first surface, this is the second surface, you are keeping on. You apply the force on the first surface, right? You are applying the force on this first surface. Okay. Second surface applies a force in the opposite direction against your motion. You understand? This is what we term as frictional force. Simply, you are trying to pull or push one of your friend. Okay. You are giving a force to pull him, but he is giving a force in the opposite direction not to be pulled. He's holding up. Imagine. So something like that opposing force. Opposing force. You are trying to move a cupboard, loaded up cupboard. It's hard for you to move because opposite direction there is a force given by the ground, the floor against your motion. Against your motion. You are trying to push to my left, let's say, to the right from the ground. It is exerting a force between the contact surfaces. So this is friction. Friction. So 2 points you learn now. One, there should be two contacting surfaces, and you have to apply a force on the object to move. Okay, so that there will be a force and a resistance, a resistive force, frictional force acting against the motion. So accordingly, how do we define the forces acting between two contacting surfaces which prevent or retard the relative motion? Relative motion. It's trying to stop your motion, retard, it's slowing down your motion. And this property we term as friction. The force is frictional force. The property of this retarding, it is the friction. Okay. Hope you could remember this diagram. We learned the last part also. Okay. You have an object. You are applying the force to this direction. You can see you have to apply a force. The force may be less or more. You have to apply a force. And between the contacting surfaces, you can see the friction is acting. Correct? This is the force you apply, and there is a friction. There is a friction. Okay. So you see, if your force overcomes the opposing force, if your force overcomes the maximum opposing force, the object will be moving. Object will be moving. Accordingly, this friction when we are taking, we got three types of friction. How many types of friction are there? Three types of friction. Right. That is something like, we take the object here, the common object. This is a force you apply. Force applied. Two contacting surfaces are there. You can see. In between the contacting surfaces in the opposite direction, the frictional force is taking place. And if it is moving, it moves by unbalanced force. Can you remember the equation of this? We learned that. Yeah, if there is an unbalanced force, that is equal to what is the force you apply should be reducing. From that, the friction we have to reduce. Right? So you can find out the unbalanced force. Now the types of friction. When you're going to take the types of friction, we got three types of friction. We got three types of friction. What are the three types? Look at this. Very simple. I'm making three objects. Right? Same three objects, let's say. I'm showing you like the same because the size, the mass when it is changing, the friction changes. That will be learning in the next part. All to the board. Now you are applying force. Okay. You are applying a force. I'll take it as X. Between the contacting surface, once you start applying a force, there will be a force in the opposite direction. I'll take it as FR, friction. Right? Let me see. A cupboard you're gonna take. You're slowly adding a force, applying a force, but the cupboard is not moving. As far as you don't apply a force, there is no friction acting. You start applying a force, there is a friction. But at the beginning, you can see you can't move. Let's say you are giving a small force, the object you can't move, but you are applying a force. What's happening? The force you apply here is less than the friction. Less than the friction. Because friction is moving. Friction has a maximum value in between the contacting surface, and that is depending on the surface. There's a maximum value. There are 2 points. There are 2 points. Now, directly we don't take the mass, we'll take it as a different word. We'll learn, right? So, the force you apply is less than the friction. Friction is more. Friction is more here. As the friction is more here, you see, what happens? Object will not move. Object can't move, right? Because the force you apply is not sufficient to move it. So, what happens here? Object doesn't move. It is at rest. It is at. So at this time, what is the friction acting? We name it as static frictional force. What is the friction? Static frictional force. Right? Static frictional force. Now, somebody want to move the object, you are increasing your force. Let's say earlier you applied 50 Newton. But I told you, friction is more than the force you apply because friction does have a maximum value, let's say. The friction is 80 Newton. That means the considered two surfaces, in between that, the maximum friction it can apply is 80 Newton. For an example, it is not always 80, okay? Maybe any amount. Just an example, 80 Newton. Now, you are applying 50, right? 50 is less than 80, so you can't definitely move. Now, what do? You are increasing the force. Now, you are increasing the force on the hub. When you increase the force, at a time you can feel the object is ready to move, right? You can feel that, right? Object is, you are hardly pushing it. At a time you can feel, the object is ready to move. One more force you give, it will be moving. That idea you will get, right? So this is on a minute to move, is it's ready to move, just beginning to move. At this time, what happens? The force you apply, you increase, right? You increase up to the maximum friction. The force you apply here has become equal to the maximum friction. Force is equal to the maximum friction. This friction is maximum, right? Maximum friction. 80 Newton, for example, you also increase up to 80 to 80 time. It's balanced. Now you can feel the object is ready to move. What you can feel? Object is ready to move, but not yet moving, okay? Object is ready. It says I'm ready to move, you give one more force. I'm moving then. Okay. Now what do you do? Okay, I'm giving a Newton move. Earlier, when you increase the force, friction has a maximum, it went up. But now the friction can't increase because almost it is maximum. Maximum means you can't increase more than that, right? Friction maximum it is reached in the second instance means it can't increase more than that, right? Maximum means more than that you can't increase, right? But your force is not like that. No, you can apply any of the forces. You can accompany with the paper or using any gadgets, you can increase your force. Now you increase the force than the maximum friction. Your force is your force is now what happens? Object moves to the direction of the force. Why? You have overcome the force. Your force applied is more than the friction, unbalanced force is given. So it's moving. It is moving. Right? So you see, force applied is moving. So there is a direction. So what type of quantity is it? Is it scalar or vector? Any type of force you take, all of them are vectors. They have a magnitude and a direction. Now is your accordingly. First type we took static friction. When it is equal, it is called limited or limiting frictional force. Limited or limiting frictional force. And now the force is more than the friction, it's moving. An object in relative motion is moving. What is the friction acting? It is not the maximum, it is less than the maximum. Why? A person is holding up, giving the maximum, he is holding up, not to allowing you to move him, push him or pull him. But somewhat you have increased your force more than his maximum means. Okay, he has to reduce his force. Now, why? He knows now he can't definitely increase more than that 80. For example, you have gone for 100, 120. How much he tries, he can't go beyond 80 means. What is the use of giving 80? Useless, no? Giving hardly no need to give that 80, no? So he reduces the force. Likewise, at this point, the third point, once you have increased the force more than the maximum, it won't retain at the maximum, it reduces the force. Understand the point? Friction will not remain as 80, it reduces because useless of remaining 80. Why? Already you have overcome it. Understand that practically. But theoretically, as for the calculations, we take the questions, the data is given, right? So at this time, what is the friction? We name it as dynamic or else relative friction. Dynamic or relative friction. So these are the three types of friction. Three types of friction. You understand? So static friction, that is the friction acting on an object which is not moving even though you apply a force. You have read that word. Even though you apply a force. Without applying a force, there is no friction. Object is ready to move because your force has become equal to the maximum friction. Limited friction or limiting friction. Dynamic friction, object is moving, it is in relative motion. Now the friction acting against your motion is relative or dynamic friction. Your force is okay, and there what is the force applied? Unbalanced force. Did you understand the point? Points clear? Very, very simple. Three types of friction. Three types of friction. Clear? Okay. So one by one, shall I take the note page, please? Go to writing book, please. Go to writing book. No, no, definition only. Take the topic, unit 5, friction, and then draw the first diagram and then the types of friction. You can pick to draw it. Don't use these rulers and all here, okay? Okay, done. Right. So, what are the vectors affecting? And you can see the static friction. Force you apply, opposing direction, the friction is acting on, velocity is zero, object is not moving. So, how do we define static? Frictional force that act when there is no relative motion, even though force is applied. All these notes are there on your tube. Okay, how to read them? And what is the second one? Limiting frictional force. That is the friction, the maximum friction acting on the object as it is beginning to move. It's not moving. It's not moving. It is beginning to move. Same content if it is there, fine. Okay, you don't want to write the same. I mean, the entire thing the same definition. The description you can write in your words, but the meaning should be there.
Like the object.
Body force.
This the force.
Force.
Equals the maximum.
No. You don't want to make it complicated. Maximum force. That's it. Equal to maximum, you don't want to say. Maximum force acting on the object. Okay. Maximum frictional force acting on the object as the body is beginning to move. Now, in your words, you are writing as the object is moving. Is it correct? Wrong. As the object is ready to move or beginning to move or just begins to move. Anything like that. If you are giving the idea that it is moving, that falls under relative friction or as a dynamic friction, which is wrong. Got it? So, next one. Dynamic friction, object in motion. Object is in relative motion, but is a friction acting. Okay, we have to say the friction acting, okay, not the force acting. Or else you have to say force acting against the motion. So it's easy to say frictional force, right? Frictional force, object acting on the object when it is relatively moving. That is called dynamic friction. Dynamic friction. So those three diagrams are what we have summarized here. Right. Next we come to the factors affecting the frictional force. There are two factors affecting the frictional force. Right. What are the two factors? Number one, perpendicular reaction force. What is the first one? You can see here, perpendicular reaction force. So perpendicular reaction force, here you can see. Now first thing, what is perpendicular reaction force? When you're going to take an object like this, it has a weight, let's say, equal and opposite upward, there will be a force. We are standing, right? We have a weight. Weight is a force, no? A force is acting on the object downward, means it should be pulled downward, right? This is a force, this is object. You are giving a force down, means should be moved downward, right? Are we moving down? Are we being sinking down? No, right? Why? Because we are balanced by an upward force. We can't see the forces. We are balanced by an upward force. This upward force we term as normal reaction or else perpendicular reaction force. Perpendicular reaction force. All of us, including all these values, we have a normal reaction. Upward force is there. This upward force is what vertical balancing force. Any object at rest we take, weight is down, upward force is perpendicular reaction force. Okay, at rest. So even if it is over a surface, the same thing. Object weight is down on the same line upward, equally normal reaction applies. See, two instances, the same person is pulling two objects, same material, but one is larger one, heavier. The other one, smaller one, light. Heavy and light. Whom you think you need more force to move? A, right? Why? It is a bigger object, larger object. What actually means here? Heavier the object, mass is more. Mass more means weight acting down is more. Weight acting down is more. So you see here, right? What happens? You're gonna take an object. Two objects you take. I'll take it as A and B. It's a small object. It's heavier. A heavier mass. And this is a light mass. M means mass. Now the weight acting downward is W. Let me take it as WA. Instance A is there. Instance B. And the weight acting here, I'll take it as WB. You can see the length also I have taken less to show that the weight is less because the magnitude number value is what denoted by the length of the arrowhead. Okay. So equal to the weight, you have a force upward. On the same line of action, you have to take a straight line. That is reaction force. And here equal to that upward reaction force. When you are applying a spring balance to move it, whom you need a bigger force to move? Definitely the heavier one. Why do you need a bigger force to move it? Because opposing force is high. If the opposing force is less, giving a small force, you can move it, right? If the opposing force is more, you have to give a bigger force to move it, correct? So when you are applying a pull or a push to move, you can see the heavier one, you need a big force. That is because of, what's the reason? As the weight is more here, reaction force is more. Reaction force is more. When the reaction force is more, the friction applied in the opposite direction. Let's say this is the force you apply. Okay, this is the force you apply. The FA and FB. The friction acting at A is more than the friction acting at. So it's clear to you that frictional force is directly proportional to the perpendicular reaction force. Correct? Frictional force is directly proportional to the perpendicular reaction force. Perpendicular reaction force or the normal force you increase, it becomes more hard to move because of frictional force. Simple example. Different prints you got with. Okay. I told you this example earlier. Tomato and pumpkin. Right? A tomato and a pumpkin, you are going to move, you are going to pull a bush. Who is easy to be pulled? Tomato. Tomato. Okay. So tomato is easy to pull. Why? Because less in mass, lighter. Okay. Pumpkin is bit hard, right? Heavier. Likewise. When the mass is high, the weight is high, the perpendicular reaction force, the normal reaction is greater. So friction would be high. So you need a bigger force here than the second one to move the object. Clear the point? Clear the point? So that is the first case. Second case in your take. The second one. There is the first one. Perpendicular reaction force. This is what I have taken as R. Second point. Nature of the contacting surface. Nature of the contacting surface. Now look at this. I'm going to take two objects, same two objects. Okay. Same two objects. One is kept over a smooth surface, a flat smooth surface. The other one you can see it is not flat. I will term it as a rough surface. Same mass. instance A and B are there. You're gonna apply a force here, FA. Here you're gonna apply a force. Whom you think you need a big force to move? A or B? A or B? Is it on a smooth surface or a rough surface? You need the bigger force to move the same object. Rough surface, right? Imagine on the board, you can easily move. Same speed, can I move it on the wall? No, why? It's rough. It's rough. Okay. When you move your finger over your face with makeup and without makeup, experience. With makeup, it's easy to move. No, even a cream or whatever you apply with makeup, with a sort of cosmetic, you have a good experience. I know that, right? Okay, you have a lot of things at home, right? So, sisters, right? When you move it, easy it moves. Without that, nothing on face. Relatively, it is hard, right? Clear? Because it gives a lubricating due to the oil, ointment, or cream, or whatever you apply. So it becomes smooth. So I see smooth surfaces are giving a low friction. So the friction here would be less, and the friction acting over there here would be more. So when you take the roughness, A is less than B, B is more here. So the friction when you take it. Friction of A, friction of B you take, B will remove. We don't speak about the reaction force here because mass is same, right? Mass same means weight will be same, reaction force will be same. Same object. But two different surfaces. Contacting surfaces are different. You understand the point? So these are the two factors affecting the frictional force. Now there's another factor that does not affect the friction. Does not affect. Now, usually throughout science we learn what are the factors affecting. So far in 10-11, this is the only point like we can say where we learn about which does not affect. All the factors we are learning as affecting one, which is impacting. Not impacting, this is the only factor. Then why do we want to learn? That's because you may have a big misunderstanding otherwise. Imagine now, a person is standing, who is sitting down, who is lying down, who is any other angle is there. Okay, to pull him from the same surface, the force you need. What can you say about? At which instance the force you need is more? When he is sitting down, lying down, or standing? What do you think? Horizontal force. Not like this you are going to apply. Horizontal. Horizontal means same. If the object is in this way, you are giving a force here. Object is here, you are going to give a horizontal force. Horizontal force. Not an angle force. Angle force would be hard. Horizontal force. Whom do you think more force is needed? Same force you need. Same force you need. Same force. Why same force? Why? Whatever the angle is there, did he change his mass? When he is lying down, mass is more. When he is standing up, mass is less. No. No, right? Okay. Only what is changing there is the contacting surface area. Contacting surface area. So earlier, what is the word we took? Look at the difference. Nature of the contacting surface. What is the structure? What is the texture of the contacting surface? If it is rough or smooth. Here we take the area, contacting surface area, not the nature. Whatever the surface area does, it may be like this or this or this, whatever. Mass is same, right? If the mass is same, perpendicular reaction will be same, right? Because the weight is same. So no matter whatever the surface area it is contacting with, as far as the same object and on the same surface, friction will be same. Friction will be same. You have to apply the same force. But angle of force should be also same, horizontal force. If you are changing the angle, it will be different. So horizontal force would be the same. You understand that? Unless no external forces are given. Okay. And also he should not be holding himself, giving different forces. Okay. Without that, he is loose. Same way, you are giving the same force, you can move. You can move. You can find it using a spring balance or something. Asking him to hold it up. But the thing is, he has to balance himself without giving a force. Okay. Otherwise, if he is holding up, that means you can't move. Right? So anyhow, you see, accordingly, oh, you can take an object. The table you can take. Table you are going to keep it horizontal or vertical or the upright down, whatever. Horizontally you are going to go pose. You can see the same pose you have to apply. Same pose you have to apply. But the problem is this table should be having the same surface all through. But here you can't. Why? In this surface, these are different surface. Surface naked. And here a different surface naked. Right? So it should be having the same surface. That's why I told you. Surface should be same. Only the area is changing. So it's clear that surface area does not affect the friction. Surface area does not affect the friction. So no matter whatever the surface you gonna keep. Let's say this object. Okay. You are keeping it over there. And again you are going to keep it like this. By this surface. And again you are going to keep it by this surface. Three surfaces I have taken. Can you see? Three surfaces. Surface areas are different way. Then you're gonna take surface area. Let's say A, B, C. Not equal, right? More or less, they are not equal, right? But mass is same. Same mass. So when you take the friction, will be the same. Friction will be equal to all these points. Did you understand? There is no change in the friction because the mass is same. Surface, contacting surface is same, only the area is different. You understood the point? Clear? So this comes as it is. I have given you a diagram on your tube, like a common diagram. It comes in the question, especially in MCQs also. So remember, only two factors affecting the friction. What are the two factors? Perpendicular reaction force. When it is increased, friction increases. When you decrease the perpendicular reaction force, friction decreases. Nature of the contacting surface, you increase the roughness, friction increase, you decrease the roughness, friction decreases. Contacting surface area, not the total area. You don't take the entire area of this, not the total. Only the surface being contact. Surface being contact. Contacting surface area you are taking, it doesn't affect the friction. Got the points? Clear? We'll quickly take note. First part, take topic, factors affecting the friction, these two, and then factor that does not affect the friction, this part. Please go ahead. Hurry up. Examples will speak. They are coming under applications. Seminar. We need seminar actually.
We need a seminar.
Need but not tomorrow. When is it?
Third.
That is why for wait I plan a seminar because different days. Some of them next week, some of them the following week, some of them the next month. Those like. Now, how many of you need a seminar actually? How many of you need a seminar? One, two, three, four. What about others?
I used to.
Exactly. Me. Yes. Finish. How many chapters? We say that yeah. No, exam I think because you guys are not continuous, but still the paper is ready. That's not paper is ready, but next day will be probably next month will be ready. We didn't have time for the seminar this time.
Before science exam, but don't feel like you will be on the exam. Somehow,
Anyhow, you should be able to go for all the exams, and you should have learned all those things before the exams, not during the exams. Don't cut the classes during the exam. Right? During the exam, don't never cut the classes, right? You have to get prepared for the exams early. Because when you doing the research, always the same time. This is easy, that is easy. No, you have to prepare. Everything you have to prepare. Okay? Fine. We'll see. We'll see. I'm not having an idea to do the seminar this time.
no, only can.
Okay, if we are having tomorrow, how much can it become?
Tomorrow.
That's what I'm thinking about. Because I am thoughts in some of the schools they are having sports meets.
I should.
Different programs are. I'm very tough. Now this time you get prepared in your own and do the exams. Anyhow, I have done that. Syllabus I have done. You do revision. Why not we did the questions? I gave you question papers and all. We can discuss some of them, isn't it? Where are you?
What is first two chapters?
Yeah. Third chapter you did get. SK paper. Ah, see? Third chapter you get.
Okay, nice.
So you should nicely remember the things as well. Do the exam.
Revision, one revision.
Little. And that's all.
You said physics is hard, but the third chapter is chemistry.
Six now, okay, when you press.
Do revise before the exams.
Last 30 minutes, I will do the exam.
Right? I don't have the paper today. Paper is ready, but I don't know. I will pay you guys. You can pay it. Even half an hour not being paid, 8 or 9 hours. Still some of the people, not coming to the class again. Fine, man, hurry up. Please write it down quickly. Hurry up, hurry up. Hurry up.
Tomorrow, one and a day, tomorrow, so tonight, once.
This is what we spoke about now. Yes. Surface area, you can see whatever the surface area you apply a string current, you are going to move it. You can see same force you need to move. No matter what is the contacting surface area, object is same. Object is same. Right. Next. What are the advantages and disadvantages? But before that, can you please fill up the tune? Go to tune, please. Go to tune. Here we are. Factors affecting the friction. Let's write down. Perpendicular reaction force. Perpendicular reaction force. Here we write. Perpendicular reaction force. Nature of the contacting surface. Nature of the contacting surface. Nature of the contacting surface. Okay. Perpendicular reaction force. Second one, nature of the contacting surface. Nature of the contacting surface. Okay. So this speaks about three diagrams are there. Three of the objects are there. You can see only 1, 2, 3. Whom you need more force to move? Third one, right? Why? Perpendicular reaction force is more. Why the weight is more means perpendicular reaction will be more. If the perpendicular reaction force is more, force you need to move it would be more because the friction is more. Friction is more. That's the idea. So accordingly, let's write down. What is the speed here? Does the text box given right? There we write weight W is equal to perpendicular reaction force. Perpendicular reaction force. Weight equals perpendicular reaction force. Weight equals perpendicular reaction force. The next one, accordingly, let's write down the dotted lines. Accordingly, quick life accordingly. The frictional force increases accordingly. The frictional force increases frictional force increases when the perpendicular reaction force is increased. When the perpendicular reaction force is increased. When the perpendicular reaction force is increased. Okay. Frictional force increases when the perpendicular reaction force is increased. Okay, next one. Two surfaces are there. Will you please mark me a smooth surface and the rough surface? Okay, and you can see smooth surface, the friction you need would be moved. Rough surface, the friction acting would be moved. The force you need to move would be moved. Smooth surface, it would be less. Okay, so it would be observed that the minimum force applied to move the object increases with the roughness of contacting surface. Roughness increases means you need more force because the friction is high. Friction is high. Accordingly, let's write there. Accordingly, frictional force increases. Yeah, all right. Frictional force increases when the roughness of the contacting surfaces increase. When the roughness of the contacting surfaces increase. Frictional force increases when the roughness of the contacting surfaces increase. Right. Look at this. It's about the surface area. No matter what is the surface area, if the object is same, contacting surface is same, friction will be same. Accordingly, the contacting surface area does not affect the friction. Does not affect the friction. For the same object. For the same object. The same object. So, right. Advantages of friction. What are the advantages? Can you see? You are walking, running, whatever. Right? Now, the tendency of spinning down is reduced because of the friction. Why? When you talk about the shoes, slippers, and all, including the vehicle tires, all right? We do have some cuts, right? Beneath the grooves, we say, the grooves are there, the cuts are there, all right? So these grooves are being applied in order to make the surface soft. To replace the roughness. But you know, when we are going to buy the shoes and slippers, what are we looking for? We are looking for the pattern. Some of the people, when they are buying the shoes or slippers, they are checking out if it is nice pattern view. No, check it. It is something that when you are walking, this is how you are walking. What is the use of looking at the pattern? They are nothing. Because it's gonna be below your feet, isn't it? You are not going to show it out. Right? So anyhow, that mentality is created. People look for that, right? They're looking what is the pattern, what is the design behind. Ultimately, why we are using that is to increase the friction. To increase the friction. More the cuts, more the grooves, roughness is high. If the roughness is high, you want to sit down easily. You'll be balanced when you are moving. Even the shoes, slippers, including vehicle tires. Vehicle tires are the same. Different cuts are there. Different cuts, different grooves are there. Okay, to make the surface rough. Got it? So that's the point where we are using the higher friction. We are using the higher friction. So reform is easier skidding. But still accidents take place, right? That is because of the speed. One. The other one is maybe the brake is not working. Okay. Oh, the tires are worn out.
Maybe he's done.
The tires are worn out, slippers are worn out also. When the tires are worn out means actually, for a long time when you are using it, the roughness reduces, right? Even the brake pads when you are taking. So around the bicycle when you are taking, to the wheel, when you apply the brake to this ring, there's a small part connected ring, a brake pad. It is a rough surface. Okay. When you apply the brakes, it presses over the wheel, the remove the it stops. For a long time when you are using that, the roughness keep reducing, right? Why? It's getting contacted continuously. When it gets contacted continuously, it is rubbing over, it's sliding over one another, the roughness reduces. It is something like pollution, isn't it? Okay, it's pollution. So it reduces the roughness. It becomes smooth now. So that is why after a while you have to replace the brake pad because no more rough. Okay, no more rough. So like the same the tires when you take for a long time when you are using for a number of years, okay, there are certain number of years that you can use depending on. So it gets worn out. Sometimes it tears up. For a long time when you are using, where the thickness has been very much reduced because of. So even a small tone pit totally goes. Okay, it may happen. Right? Slippers also the same. When you take the slipper out, you can see how many years you have used. Because if it is totally worn out, mostly not happen. When you're gonna take the slipper, this space, sometimes you can see there's a hole. Correct? Why? That much is worn out. Right? So anyhow, you see, friction we are using. Friction we are using. But the same thing, specially designed slippers are there sometimes. Some slippers, let's say, have designed to be used in the sea coastal environment. Sea coastal environment. And these slippers, they are very flat. They don't have much grooves. No more cups. Simply flat. But nothing happens. You know why? Because you are using on a dry sand where nothing is moving. So you always remember. What do? Buying that slipper, you are going to wear it inside the washroom. Huh? No stopping on the floor. Correct? Why? It's you don't have that purpose. Anyhow, the tiles are because usually the wall tiles might be soft, smooth, but the ground tiles in the washroom you are using it as well. Sometimes pebble like design should be there. Actually, public washrooms are all we are taking up. Sometimes the rubber carpets are there. Okay, why to make the roughness smooth? Designs like all they are making the pebble designs and all, but things. Now nowadays you do have the stickers, right? Stickers seem to sticker ground flooring stickers are there. Those stickers on your plate seem to be like pebbles, but totally smooth. Totally smooth. When you keep it on, you may stick down. Okay, even a rough slipper you have. Let's say you apply some shampoo with soap or something. Can you dance over there? No. Why? Lubricating the surface. It's lubricating surface. Oil nature. Okay, water in liquid nature increasing. So this reduces the friction. You can easily sit down. And that is why when you are washing the home and all if it is tile or soft surface, just applying some detergent powder, water, whatever, you can slowly sit down. But you have to balance. Okay, that's because of friction is reduced. And moreover, the vehicles when you are taking, water is surface, muddy water, or they can't break. It's hard to break up, right? Why? Liquid. In between, and that is why during rain, we have to make sure you control the speed because we can't break. We can't apply the brakes. Okay, because the friction is this. Got the point? So accordingly, this is about the advantage, and some more advantages are there. What are they? Striking a matchstick when you are taking, you have to strike it on right. It's not a smooth surface, right? It's a rough surface. For the rough part, the rough surface, you have to strike. So rough surfaces when they are striking, it gives a friction. So simply when you take the hand, when you rub it one over the, you can feel it's getting heated, right? For a long time when you do that, it's getting heated. Even a number of times when you do, you can feel it's getting heated. Why? Because it's rough. So rough surfaces they are making, you can see it's increasing. It's higher the friction, it increases, it results in heat. So these advantages and disadvantages both. Advantages striking a matchstick, so it burns, giving a chemical interaction. So we are using that fire. Spike shoes or in the sports players or sports shoes or whatever, spikes are there in order to increase the friction, so they won't be easier slide down. Okay, falling down, right? And we are able to drive the automobiles because of the vehicle tires. Tires are having grooves. And even writing on a pen with your tape, you could have seen the pen you take, okay, over there are some circular cuts or straight line cuts are there. Why? To hold your fingers on, not to move it down. Even your palm when you are taking, this area is soft, not soft as the upper part, right? I mean, the area, the roughness is there, and also the hold up and the pressing ability. So, anyhow, as a material, when you take this area, when you take, it does have some sort of regions with a high friction. Roughness is oh. Or sometimes you'll be having a rubber pad also around it in order to not to move it, slide it down. Okay, so all these are advantages. Many more advantages are there. So, what are the disadvantages? If the force is frictional force is more, the force you need to move the object will be also more. Right? Can you remember earlier? Bigger mass will force you need to move. Why friction? So the energy you have to apply is more. The force you have to apply to move the object will be more if the friction is high. That's a disadvantage. And the energy input will be more. Why? Now imagine a grinder you're using. Grinder. When you use, why are you using this grinder? It grinds the. But is that 100% of energy we apply is used for that? No, right? A nice sound is going to okay. For you to dance. Yeah. Okay. It vibrates something. So is it this sound? Are you using? Are you using that sound? No, right? And it is heated up also sometimes. Are you using the heat to boil water? No, right? So is it the sound and heat is lost now? Where is this energy coming from? From the internal, the input energy. We are giving the energy, we are the electricity. Let's say 100 joules of energy I am giving to work an object. It is using somewhere about 30 to 40 joules of useful. That is my useful energy. 50 to 60 energy, joules of energy is lost out. So it is a loss of energy. More the loss of energy, more input energy I have. Why? To work the to operate the. So you see, energy loss is new when the friction is high. When the friction is increasing, energy loss will be more, and that is why usually apply these oils and oil between the contact and surface of the machinery parts. Machinery parts between the tools we apply, right? Same thing can you do now. When you learn the theory, properly how to learn, right? Okay. So to increase the smooth working, to reduce the friction, we apply. Have we learned that we have to apply for it? We are going to apply the oil inside the motherboard of the computer. Correct? Properly how to apply. Here is practically apply. Okay. You are applying water. Nowadays, you have much technology is there. There are CPUs. Even inside water use. Okay, water system. Water system. Okay. Now we are learning our water system. CPUs. Going home, you are taking your CPU and putting inside water. Is it water system? Right? Properly how to apply. Right? So now the friction is reduced when you lubricate. Friction is increased when you increase roughness. Okay. So causes forest fire. Why? Forest fire is because of many reasons. One of the reasons is contacting surfaces when they become rough because they are dried up inside, dried up leaves, stems, branches, and all they are rubbing on one another. I told you the heat will be generated. So this heat will be resulting in fire. So it may be starting a forest fire. Okay, and this causes noise pollution. An aircraft moves, the big sound is produced. Vehicles will be moving, the big sound is produced. Are we using that stuff? Which is loss of energy. So these are disadvantages. And the materials can be wearing more or tearing apart very quickly. Okay. So they will be getting worn out or torn very quickly. That's because of friction is high. Friction is high. Okay. So they are the disadvantages. So how do we increase the friction? To increase the friction, we can cut grooves, spikes, we can apply. We can cut grooves in the vehicle tires. Okay. Cutting grooves. Or else, let's say we can't cut grooves. Below the furnitures, we can't cut grooves, right? What we do there? In between the contacting surfaces, we're gonna keep a sandpaper or a hard material. Or sawdust. Okay? Some sort of what they call hard or rough materials you are going to keep. And vibrating pads you are going to keep. Okay, shock pads you are keeping. So what happens if you want to move it? Because of the roughness. You are keeping rough. So imagine now, when we are moving, it's generating heat because of roughness. Same thing when you keep this marker between your hands and is it that much hard? No, right? Easy you can move, right? And that won't be creating a heat, right? Why? Friction is less. Why the friction is less? Surface is smooth. Surface is smooth. So, like that, to reduce the friction also we can use. So, these are to increase the friction. When you apply rough surfaces, increases the friction. Increases the friction. And also, let's say you are adding a very close object. Now, this object you do have. It is having, let's say, for an example, one object is there 10 kilograms. 10 kilograms means 100 Newton. Now, over that 100 Newton object, another 5 kilograms you keep additional. Then what happens? Total weight is increased up to 15 kilograms, 150 Newton. Then the force you need to apply would be more, right? Why? When the perpendicular reaction force is increased, earlier 100 Newton, now 150 Newton. Friction increases. So to increase the friction, extra weight you can apply. That is why if at home also to stop the motion of some objects sliding over the tile, you are adding some weights over. Okay, to increase the weight, so that it won't be moving. It won't be moving. So these are some methods to increase the friction. Frictionless. In a muddy floor, when you are taking, friction is less. But if it contains sand, mud with sand, then the friction would be controlled, would be high. Why? Sand is totally there. Muddy because of some water. Sand particles are there, let's say. Okay, somewhat it will be reduced. But the thing is, still, let's say the clay is there. Somewhat clay is there, it is frictionless. Because clay is a sort of, reduces the friction rate. Smooth surface, like it will be reducing the friction rate. But it contains sand. Sand particles are there. Solid particles are there. Where it is not dissolving. Now it is giving a roughness. Friction is less. You can move fast. You can move fast. Okay. How do you decrease the friction rate? Applying oil, lubricants, grease between the contacting surfaces. Okay. Oh, you apply some powder, talcum powder, boric powder, dancing powder. Also, we say pastel or whatever the powder you apply, it reduces the friction. Reduces the friction. And that is why on the carom board, the disc move very faster, very easier because of the powder, right? And these things you could have seen. You have to learn them. Okay, because sometimes what you do when you are observing these parts, you are removing out these metal balls. Especially in the bicycles are now, you could see. Some areas are there where small metal balls are there. They are doing your work, not to be taken out quickly. What are they doing? Something like this. Contacting surfaces. Between the contacting surfaces, it is giving a soft surface. So that the sliding is easier. Sliding is easier. It will be moving smoothly. Moving smoothly. So you see, these metal balls allow the surfaces, allow the particles to easier slide. Easier slide. So this is called ball bearing. What bearing? Ball bearing. And roller gates are there. Long rods are being used. Roller bearing. Okay. Roller bearing we are using. Smooth, surfaces we are using on in order to make it smoothly move. And anyhow, eventually we have to apply grease. You have to apply grease. Why? To lubricate it, to reduce the friction. And the slides when you are taking, what if they are rough? Can you slide over? They have been made smooth, right? So that smoothly you can make by smooth surfaces, reduce the friction. So easy you can move. Okay, so that's one thing. And why are they usually, if it is a metal surface, why are they being silver, not black? If it is black, you can't get it on. Why? Black absorbs the heat most. Silver reflects the heat most. Silver shiny surfaces, they reflect the heat. So that heat would be reflected out, it won't be very much highly heated. So two theories are there. And here we are speaking about smooth surface. Being smooth, you can slide easily. You can slide easy. Got the point? So these are some examples where we can reduce the friction. And there are some applications of this friction. Some of them we spoke about. The shoes, slippers, vehicle tires and all. You can see sometimes the people they are climbing up the mountain, the workers actually, and climbing up the trees. They are wearing, okay? They are sending around a sort of what do you call a rope, a huge rope around their waist, right? Huge rope. And what type of rope it is? Fire rope, right? Isn't it? It's a fire rope. Why? Fire rope, fire fibers it is used to make, and these fire ropes are giving a high friction. Friction is high. As friction is high in fire rope, you want to be easier stepping down. Between your body and the contact with the other surface, you do have a surface. It increases the friction. Same thing you can't use as a nylon. Nylon rope when you are taking, nylon is a smooth surface. Compared to something questions. Nylon is a smooth surface. So easily you can unlock. Okay, and also it won't be giving exerting that much of friction. It lets you split down. Okay, so question asked me like this. Knots in a firework is hard to remove, while in a nylon rope it is easy. For the reason, friction is more in firework, so it's hard to remove. Friction is less there, it is easy to remove. Easy to remove. Okay, so the brake exhaust system also. Okay, exhaust system also say that we are using a friction. Why? Higher the friction. Okay, because friction is given high, it stops. Stop doing right. And today in the modern systems and all, we are using oil. Oil will be transmitted towards the cylinders. There will be a dispatch. Over there, forces apply, it presses and stop the vehicles fast. Okay, so anyhow, all these are examples that we are using. Furthermore, some examples are there on YouTube. You have to read them completely. Okay, I have explained the entire part. Entire part I have explained with the examples. Okay, so it's your duty to refer the tune at home. You have to totally read. Okay, you have to totally read. Now the reading part hereafter I'm giving you to be done at home. Basically, these activities and all. Okay, we fill up the tune and we take the last a few pages of the tune. We have to fill up the notes, especially the disadvantages onwards. I think, right? Correct. What's the page number? Disadvantages, I think. Disadvantages of friction. Page number 14, right? Just right there. More force is required to. More force is required to. More force is required to move an object. 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 And next one. Contacting surfaces could be worn out quickly. Contacting surfaces could be worn out quickly. Contacting surfaces could be worn out quickly. And the next one. Energy is lost as sound and heat due to higher friction. Energy is lost as sound and heat due to higher friction. Due to higher friction. Next one. Causes noise pollution. Causes noise pollution.
I don't know some writing this energy loss due to friction.
Not to be hurried. Listen and write in terms. Next one. Higher friction. Between the dry leaves may lead or may cause forest fires. May cause forest fires. May cause forest fires. Higher friction in dry leaves, between dry leaves, may cause forest fires. Right. Methods of reducing friction. Application of next topic we are taking, okay, application of oil, grease, lubricants, oil, grease, lubricants in between the contacting surface. Oil, grease, lubricant in between the contacting surface. in between the contacting surfaces. Next. Application of talcum powder or boric powder. Application of talcum powder or boric powder for the contacting surfaces. For the contacting surfaces. For the contacting surfaces. Next. Third one. Application of ball bearing.
Application of
Not boring. Boring powder. Boring powder. Okay. Application of ball bearing. Not ball bearing. Ball bearing. B-A-double. Ball bearing. Ball bearing. And roller bearing. R-O-W-E-R. Roller bearing. Ball bearing. B-A-double. Ball bearing. And roller bearings. Roller bearings. Next. Making the contacting surfaces smooth. Making the contacting surfaces smooth. Making the contacting surfaces smooth. So reducing the surface area, increasing the surface area, we can't write for anything, okay? Because we already learned surface area will not affect the friction. That is why we are learning that, right? We got the next one now. Next topic, increase the friction. Increasing the roughness. Increasing the roughness of the contacting surfaces. Or we are using the same word contacting surface because what is the surface being in contact, that is what we have to change. Okay. Increasing the roughness of the contacting surfaces. Increasing the roughness of the contacting surfaces. Placing rough materials. Placing rough materials such as sand, sawdust, 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 stones, sandpaper, etc. Sandpaper, etc. Sandpaper, etc. In between the contacting surfaces. In between the contacting surfaces. In between the contacting surfaces. Cutting grooves. Cutting grooves. On the contacting surfaces. On the contacting surfaces. Such as in. Such as in. Shoes, slippers, vehicle tires, etc. Shoes, slippers, vehicle tires, etc. Vehicle tires, etc. Next, placing an extra weight. Placing an extra weight over the object. Over the object. Okay. Right. Fine. Done. So that's the end of chapter 5. Okay, not very simple, small listen, but lot of theories are there. Okay, no calculations are all theory. So please record. Please record. All 5 chapters down. Please do refer, revise all 5 chapters. All 5 chapters. Okay. So next week, I will see the start from the kind of new chapters. Okay. New chapters, but if there are changes because having the exam the next week or the day, if we are having any papers between that, we will form. Okay. So then, good afternoon. So,